and Mrs. Freeman.
Good morning, Mrs. Freeman.
It's a lovely sunny morning here in Bound Brook, and good to see you to talk with you about these questions that our boys and girls are asking about your very interesting books.
We're very eager to hear what the boys and girls want to know.
Now, we particularly liked Fun with Scientific Experiments because it explains how to do the experiments so that we can really do them.
Yes, that is the idea behind the book. We want the boys and girls to be able to read the book and do the experiments themselves. Perhaps Mr. Freeman can explain the idea behind some of these experiments.
Well, yes, we started writing these books a number of years ago when we realized that the best way for children to learn science is to actually do it. And in order to do it, of course, they must be able to work with scientific things without having a laboratory or even a science kit. So we arranged to devise experiments that were really illustrative of scientific principles and still didn't require anything that you can't actually find around the house.
And in doing them, a child could have a great deal of fun. They are fun to do. That's why we name them Fun with Science.
Are you scientists?
Well, we are, in a way. I'm a scientist by profession. I'm a professor of physics at Rutgers University. And Mrs. Freeman is a scientist by this time, I think, because she's gone along with me.
Would you like to ask about some specific experiments?
The ones that the boys and girls liked, particularly in this Fun with Scientific Experiments, were the experiments, the one standing on the roll of paper, stacking 30 pounds of books on an eggshell, blowing the dime into the saucer, heat shadows, and making a hygrometer to measure moisture.
Yes. Let me take the first one, and then you select some others. The thing that I would like to tell you about the first one is that if you'll just make a half turn of your head, you'll see the stairway where it was photographed. We set the boy up there on the roll of paper and took his picture. These were all done right in this room, or in this house.
Or in the kitchen.
Or in the kitchen. And if you look around, you will see very familiar things that you see in the book. They were all used right out of the house.
These first two experiments, by the way, the standing on the roll of paper and the eggshell that's strong enough to support a stack of books, are interesting because everybody thinks that paper and eggshells are awfully delicate, and this is really engineering as well as science because that's what the engineers take advantage of. They arrange to have materials work in such a way that they can support big loads.
Well, now the boys and girls ask, did you think up these experiments?
It's hard to say about these fundamental experiments. Some of them have been around in one form or another for a long time, and others we have worked very hard to actually bring up from scratch, you might say. The ones that I use at the university are not too different from some of these, and the whole trick, I believe, is to put them in the language of a young person and within the experience of a young person. This, of course, is sometimes very hard.
Well, this comes to the question, then, is how did you decide which experiments to put in the book?
Well, there aren't so many available that you don't have to do a lot of digging, and that's one criterion. The other thing is, of course, there are certain principles in science that are, some of them have pretty long names, and we don't care if the young person doesn't learn those names for a while. But they are important ones and general ones that explain a lot of things. So we have had to try, of course, to illustrate these important principles and favor those.
And then when there's been a choice, we've used the one that's the most fun, right? Or where you see an exciting result.
And another thing is that we have come to the conclusion that we don't want experiments that are tricks. We don't emphasize the magic of science because there is no such thing. All science is magic in a way, but there are no tricks involved. There's nothing pulled out of a hat. And even though some of the experiments are fun to do and have some surprises for most people, they're all based on a scientific principle. And we don't just give an experiment for its own sake, but we tell what the principle is.
And you do use some scientific terms which are good.
Yes, we do.
Start them in.
Yes, we do.
We had liked your Fun with Science, and so we were glad when you did this second book, fun with scientific experiments. Then you also did fun with chemistry, and we liked the experiments in this book, too. We liked how you showed us how to make our own equipment.
Isn't it nice? It's so much fun to make your own equipment.
And then you really have a laboratory. You have a laboratory that you can put away in a box, or you can set it up on the kitchen sink and go to work.
And they work just as well as the expensive bought materials. Really, they do.
And they're more fun because you make them yourself.
Yes.
Mm-hmm. In some of your experiments, we have some questions. Does anyone know the reason why snowflakes are always six-sided?
Yes, all snowflakes are six-sided, although they have different designs with 6 spikes or 6 straight sides and so on. And the reason is that ice crystals have 6 sides. That is, when water freezes, when the molecules of water get together, they come together in a certain shape like a hexagon, and every ice crystal has 6 sides.
So snowflake has to have 6 sides,
Yes.
right? Now, in the flame tests that are brought out in this Fun with Chemistry, you speak of using a gas flame. Would it be possible to do those with an electric stove?
It might be, but it's rather complicated, and it's much more effective if you can use a gas flame.
And your mother might not like it if you drop some salt or something on the hot filament of the electric heater.
Yes.
In Fun with Your Camera, you showed us examples of good pictures and bad pictures. So we would know what would happen if we did
It's
the
so
wrong
much
thing.
easier to show you what is wrong than to tell you.
Is it easy to explain why the image is upside down and backward?
You have to have a good imagination, because it really is happening, but the little arrows that are shown in most books aren't really arrows. You have to imagine what's happening.
You have to think of the light coming from every spot on whatever you're taking a picture of, a person or a tree, and going through the center of the lens. And so if light comes from the top of a tree, goes through the center of the lens, of course it goes down near the bottom when it hits the film. And if it comes from the base of the tree, it goes up toward the top of the film. And everything's turned around for that reason.
And this is because it goes through the lenses.
Everything has to go through that one place.
In Fun with Figures, there are a lot of good ideas that we can use, like sighting with your thumb from both the right and the left eye, and then figuring the distances in between. How do you know that your outstretched arm is 10 times the distance that your eyes are apart?
That's a close enough average.
For most children, that's
Yes.
just about right. So you can't be very far off if you use that idea.
If you're a little off, it doesn't make much difference. You get a pretty good idea of how far away the object is. When you get into the technical parts of using this sort of thing, you use instruments which are very accurate, and then you get a very accurate answer. But this is good and fun, and you're close enough.
And this would be true of most all children.
Oh, yes, within the brackets of the length of their
And
arm.
someone has measured this so that they know that
Yes,
this is
oh, yes.
Yes, we've done it.
We never knew before how to make a perfect spirals and ellipses, and we were glad to know how to do that. We also had lots of fun making quiver pictures.
Yes, those are very interesting, and there's a great variety of pictures you can do that way. It's lots of fun. Scientists make the same kind of pictures by using a sort of a television tube in which electrons paint the picture on the end of the tube.
This idea of the quiver picture wasn't your idea to start with, as you say.
I think we should tell what the scientific name for these pictures is. It isn't quiver pictures. It's a rather fun name. These are called lysojuice.
Lysojuice figures after the man who first looked into them. And we have simply done it here using the back of a chair and a broomstick and so on in a way that you can do it at home.
How do you go about getting materials for your books? Of course, you are scientists to start with. Do you have to do a lot of research?
None at all. We have a built-in research department. My husband is the built-in research. He doesn't have to research. This is his business. And he lives all this and knows all this so thoroughly that people come to him to corroborate anything that they have done, to be sure it's scientifically correct. Anything in any of our books you must accept is perfectly scientifically correct.
How many books have you written in all? Do you know?
Oh, it's almost 40, I would think. It's very hard to keep track. That may sound surprising, but it really is. They're quite in all over the place, you might say. There are paperbacks and hardbacks and little ones and big ones.
Are these books ever translated into other languages?
Yes, they've been translated into over 20 languages. And I must say it's a great deal of fun to get a copy of a book in the mail, which when you open it up, you can't understand it all because they're just little squiggles. And then you realize that one of those squiggles is your name. Or one of the other squiggles says fun with science. For example, in Korean or in Persian, that's a very squiggly type of printing. And many interesting things, and they are used all over the world because science is the same all over the world.
And science is fun all over the world.
Science
It is indeed.
You did a book called Fun with Ballet.
Yes.
Did you take ballet lessons?
Well, I took ballet lessons by reflection. Our daughter is a dancer, and I began to take her to ballet school when she was about 6, and I stayed with her. So I learned everything. I spent many hours in ballet school, many days, many years, and then we went to live in Paris. And she studied with one of the most famous dancers in the world there, and I spent many hours with those classes. And I was able to watch the children and know what it was they were needing to learn and decided to put it down for the girls.
Well, you like to cook because you did fun with cooking.
Oh, yes, I love to cook. I love to cook every kind of food in the whole world. But when I was married, I didn't know, really how to boil water. So I had to start from the beginning. And I thought how nice it would be if, starting from the beginning, I had a book which would tell me how simple this really could be at the beginning, because most books are a little bit frightening, these very elegant cookbooks.
Mr. Freeman, did you like to do experiments when you were a boy?
Yes, I think so. Like all boys, I started out by butchering up a lot of good lumber and wiring things and having fun of that kind. And then this soon led into a little more advanced kind of experiments. And when I went to school, I began to like science, although science in school wasn't taught in a very interesting way at that time. But I started to do a little reading and fooling around with things, and first thing you know, I was headed that way.
Did you have any exciting experiments when things went wrong?
I never had the experience of blowing anything up in a chemistry laboratory or even getting a big mess made, but maybe I'm different from some kids that way.
Did you like sports as a boy?
Yes, I did. I liked tennis, particularly ice skating. And incidentally, there's a lot of science in sports. Some of our experiments are based on sports. Baseball is a lot of mechanics in baseball, and
Mechanics being a section of physics.
Being a scientific subject. And even high jumping, things like that, they're all based on scientific principles.
Before we leave the subject of sports, I'd like to say that in Fun with Science, there's an experiment you can do with a block of ice, which tells what it has to do with ice skating. Because when you skate, you simply skate on a film of water, not on ice. And doing this experiment will explain to you what it is in ice skating that makes it happen that way.
When did you first get your first cameras? Do you remember this?
Well, I think just about the time that we were beginning to write these books. It just happened that way because we were beginning to travel a lot at that time. We wanted a camera, and we got a very good one for our purpose, and we started thinking that we ought to be able to do something besides just take pictures of lakes and rivers and trees with this, and we did.
You didn't have cameras when you were
in
school?
Box cameras, and they're lots of fun, and you can do many things with box cameras.
Well, you spoke so much of this on Fun with Cameras.
Yes, so some of the photographs in Fun with Your Camera were done with box cameras.
So you both had the box camera type when you were young?
Oh, yeah.
Are you doing another fun book now?
Well, Mr. Freeman has just finished this tremendous college thing, and he's been having to spend most of his time at it, and he's still not finished because with it goes a book for the teachers. And that's what he's doing. But I've just finished a book a couple of books. One is called Finding Out About the Past, which tells about the long, long ago past, thousands of years, and how we know what took place thousands of years. It tells you how scientists find out about what happened a long time ago, and they're very scientific about it. It isn't just guesswork. And so when you read in the paper that, well, they found a skull that's 10,000 years old, they aren't guessing. They have ways of finding out, and it's all talked about in here, in this book.
And that's your new one.
No, I have done another one recently, which is called When Air Moves. And this is about air, still and moving, but mostly moving. And it's very interesting because then it leads you into jets and rockets. And all of this is a plane being up in the air has to do with moving air. If it's not for moving air, there would be no plane in the air.
Now, are both of these out on the market? Or
Oh, yes.
Coming? They're not the ones that are coming this fall.
No, they're all new, and they're all, the new things that are coming out are for the very younger children, perhaps in second grade.
Oh.
I'm doing a little series which will tell about the stars, about water, what it is and how it gets where it is and really what it's made of and so on. I hope it'll be interesting.
Well, certainly talking with you this morning has been very, very interesting, and I know that we've been enjoying these books all along, but we're going to enjoy them much more now.
Well, tell any of the children if they want to write us and ask questions that they should do it, and ask all the questions in the world of yourselves, of your teachers, and all the fun that you have. I must say that anything we've done in the past has been useful. Whenever we've played, as he has played with wiring and lumber and all, and what I have done, all the fun things that you do, it always comes in later. You find that you've learned something and it's useful.
Which would encourage us to do the same thing.
Oh, yes, do.
Well, we do thank you, and we'll be looking forward to seeing more of your
Well,
books.
thank you.